Full screen. All right, today we are starting Unit 1, Day 1. Okay, Unit 1, Day 1, solving equations and inequalities. We're going to do pages 1 through 3 today. Pages 1 through 3, that's all we're doing today. And yes, it will go by fairly quickly. All right, we'll go by fairly quickly. So before we begin really diving into solving equations and inequalities, we need to talk about certain topics or parts of equations and inequalities. Okay, the first thing we need to talk about is what are the different parts of an expression. Now, the difference between an expression and an equation is literally one has an equal sign and one does not. Okay, now how does Coach Kimball make the difference between the two? Well, equal sign is spelled EQU, right? Well, so is the word equation. Equation also has an EQ and U. Equal sign has an EQ and U. So anytime there's an equal sign, it's considered an equation. As you can look here in our example, is there an equal sign? No. So we call it an expression. Okay? Now there are two different things within an expression. Okay? There are variable terms and there are constant terms. Those are the two big parts of an expression, variable terms and constant terms. Now, what is a variable term? A variable term is a term with, you guessed it, a variable. That makes things easy, doesn't it? A variable term is a term with a variable. Now, looking up here, who can tell me all my variable terms? Who can take a guess? Yes, ma'am. 7x, 5x, and 4x is almost correct. Okay, almost. What do you think we are missing with one of those numbers? The negative. What's in front of the 5? Subtraction sign. Anytime we see a subtraction sign, we must consider it negative. So our variable terms are 7x, negative 5x, and 4x. Now that we've identified our variable terms, there are parts to a variable term. And one of those parts is called a coefficient. The coefficient is just the number next to a variable. Our variable is x. Okay? So the coefficients are the numbers directly next to said x. And what are they? 7, negative 5, and 4. So again, coefficients is just the number next to a variable. Directly next to a variable. That's a coefficient. So that's just one part of an expression. The other part that we talked about are constant terms. Constant terms are terms that are without a variable. Are terms without a variable. Which three terms do not have a variable with it? Yes, sir. 3, 8, and negative 1. 3, 8, and negative 1, because there's a subtraction sign in front of it. Now, what this is basically saying is we can combine our variable terms together and we can combine our constants together. That's the only reason why we need to know the two parts here, to figure out which ones we need to combine. Speaking of combining, that's what we're going to talk about next, combining like terms. Okay? You can simplify an algebraic expression by combining like terms. This means to combine the common variable terms and common constant terms. So we've already identified our variable terms in the example above. They're my underlines. And we can combine our constants, which are going to be my boxes. Now, when you combine like terms, you always want to do the variables first. Always do the variables first. So I have my 7x, negative 5x, positive 4x. This is why you have your calculators. 7 plus negative 5 plus 4. Combine. Combine means add. 7 plus negative 5 plus 4 gives me what? 6. Okay. Now all of these variable terms had what variable with it? X. So we keep that X with the variable terms. Coach Kimball's strategy here. Once you've used it, scratch it out. You're done with it. That way you don't look at it again. You're done with it. I'm done with yous. So I'm left with just my constant terms. 3, 8, and negative 1. Combine them. Combine means what operation? Add. Means add. Add those three together. 3 plus 8 plus negative 1 gives me 10. Now, when I combine them, did I get a positive 10 or a negative 10? Positive. So the operation in between the two will be addition. Bing, bang, boom. Now, before I move on to the next example, are there any questions so far? Do some of y'all remember this from last year? Is something kind of jogging in the memories a little bit? A little bit. Not at all, Tim? Perfect. Perfect. Well, I'm glad we're reteaching it then, Tim. All right. All right, here are some examples. Now, we're not going to do all 6 of these examples, okay? So I'm just going to pick and choose some of the ones that I like to do the most. All right, so we're going to do 2, and let's do 4 and 6. Let's do all the evens. Let's do the evens, okay? Looking at number 2, okay? Looking at 9a. Are there any other numbers that are similar to 9a? Negative 10a. Okay, negative 10a. Those are the only 2 things in the problem, so all you got to do is combine those 2 things. Again, combining means what operation? Adding. Good. Okay, so in your calculators, 9 plus negative 10. Say it louder. Negative 1a. Okay? There is another way that you can write it. It can also be written like this. If the number in front of the variable, aka the coefficient, is 1 or negative 1, you can just write the variable itself. Either way works. Questions, comments, concerns? Okay, let's move on to a little bit more tough one. Tougher, more tough? More difficult? Okay, start with my 3x. Six x is also similar. What about the negative 4? Not similar. Good. So all I'm going to do is combine these two to get what wonderful number? Thank you. Coach Kimball's strategy, scratch it out. What's left over? Negative 4. Come on down. Negative 4. Anybody see The Price is Right? No? Have any of y'all seen The Price is Right? When they call out the people's name, come on down. Some of my references are old. Sorry. I mean, I'm not that old. Don't look at me, Tim. Okay. Now for a more difficult one. Do we have more than one variable? Yes. Okay, we have an x and we have a y. Can I combine x's with my y's? Tim is shaking his head no. I also heard no, okay, from someone else. Can't really tell who said it, but I heard it. All right. Why can't we combine the x and the y? They're different. Thank you, checkers. They are different. We can't combine them. They're two different terms, okay? When you have multiple terms, or multiple variable terms, okay, always make sure you put them in, put a little star, this is a star, okay, alpha order. Put them in alpha order. What comes first, x or y in the alphabet? X. So we're going to combine x first. Now I'm going to stop there, and I'm going to ask you right here, right now, in the next minute, to combine these in the correct way. And I'm going to come around and check, see how y'all are doing. Music on means independent work. I'm just going to quickly look at it. Do it all. I want you to do it all. Cool. Alright, so you're standing. Cool. I'm sorry. Sweet. Awesome. Wonderful. Great. Grand. Y'all are so smart. I knew that'd be really quick. Okay. So we got 7x plus 9y. Every single one of y'all got that. Proud of y'all. Awesome. Okay. Remember, what goes in between the two is what you combine this to become, okay? 7 plus 2 is a positive 9, so that's why we have a plus. If it came out to negative 9, then we would have a minus, okay? That's how we know the difference, all right? Go ahead and turn to page 2. All right. Terms with the same exponent or combination of variables and exponents are considered like terms. When combined, be sure to not change the exponent, okay? Is there anyone here that could try to describe to me what an exponent is? Higher level thinking. I just want you to give it a shot. What do you think an exponent is? Yep. How much of the number it multiplies by itself, okay? I do like that definition. That's actually not bad, okay? It tells us, an exponent tells us how many times that number is being multiplied by itself, okay? Where is an exponent located? Yes, sir? On where? Top where? Which is our right-hand side, okay? Exponents are located in the right-hand side, top right-hand side of our number, okay? So we have a variable, that exponent is that little box right there. That's the exponent. That tells us how many times that number and or variable is being multiplied by itself. Thank you. Okay? So, I have negative 15n squared plus 4n squared, okay? I can combine these two because they both have the same variable n, and they both have the same exponent squared. Because those two criteria meet, we can combine them to give us negative 11n squared. Looking at number 10, okay, I have 3x squared, 4x squared, and I have this negative x right here. Can I combine all three together? Huh? Can I? No, I can't. Who wants to tell me why? Someone different. Because this x is not squared. Fantastic. Okay? Because that x is not squared. It's not the same. Yes, it has the same variable. But the variable and the exponents must match. Okay? So because this is x squared and this is x squared, these two can combine to give me what? 7x squared. Okay? However, this does not have a square with it, so I can't combine it together. So what do? Just bring it on down. Bring it on down to the Olive Garden. Yeah. No, we do not solve because it's not asking for us to solve. It's asking for us to just combine like terms. You can just push the door. All right. Okay, so let's look at number 12. Number 12 looks fairly complicated. Okay. I have an x squared. Do I have any other x squareds in my problem? I don't. I do not have any other x squareds in my problem. So what do? Just bring it down. Just bring it on down. Now remember, the whole important thing is to be in alpha order. Alpha order. This has an x first. That has an x first. So now I'm going to look at these two here. Okay, x, y, x, and y. Just push the door. Just push. Y'all come on in and turn to page 2 of the notes. Turn to page 2 of the notes.